Your presenter is Torsten Hohe from FuelCell Energy Solutions. Come and give him a big hand, please.
Thank you very much for the kind introduction. Ladies and gentlemen, also warm welcome from my side. I'm going to tell you today about stationary megawatt fuel cells from FuelCell Energy Solutions and FuelCell Energy. A brief outline, a short overview about our company or companies, FuelCell Energy and Energy Solutions, then what we do, technology, products and services, benefits and advantages, and finally, of course, you're keen to learn more about our power plants we have already installed. FuelCell Energy Solutions was established in 2012. However, we have a long track record. It's a joint venture of the US-American FuelCell Energy and Fraunhofer Institute in Dresden. It's a perfect synergy because both companies, both organizations have plenty of experience in stationary fuel cells. The FuelCell Energy from the US is actually the largest company, fully vertically integrated company in stationary fuel cells. FuelCell Energy is doing project development, engineering, construction, design and manufacturing, of course sales, and finally, and last but not least, services. FuelCell Energy and FuelCell Energy Solutions have a long track record. We have already produced 2 billion kilowatt hours of electricity from stationary fuel cell power plants at more than 50 sites worldwide. We have installed 300 megawatts or in backlog, and a highlight is already the real existing fuel cell park in Korea, South Korea, with 59 megawatt. I will show you later on. A brief idea about the competences we have. FuelCell Energy is already, of course, overlooking the worldwide manufacturing and sales, but FuelCell Energy Solutions, based in Dresden, is responsible for the wider European area. About our technology, actually it's quite simple. It's a modular-based technology and power plants. On the left side you see our fuel cell and a fuel cell stack. That is actually the core of the plant. In the middle you see a module, which is part, of course, of the fuel cell power plant. And on the right side you see three products, actually our best sellers worldwide. It's a module with 400 kilowatt, a module with 1,400 kilowatt, and a module with two modules actually. So it's 4 stacks and 2 modules, of 8 stacks and 2 modules, sorry, with 2.8 megawatt. Our best sellers in Europe are the so-called DFC, Direct Fuel Cell 400, and the DFC 1500. The electricity generated by these power plants is either, let me check, 400 kilowatt or 1,400 kilowatt. The efficiency is 47%, a bit more or less, 2% plus or minus, and the exhaust temperature we have is around 400 degrees. So finally that means we can extract heat at 120 degrees for the 400 power plant of 245 kilowatt. It's 360 kilowatt at 50 degrees. And for the larger plant, it's at 100 degrees, 649 or 1,092 kilowatts. How is a fuel cell power plant configured? Basically, we have 3 larger parts. Of course, the green is this is, by the way, an example from the biggest power plant FuelCell Energy Solution is producing. It's 2.8 megawatts. The green is the fuel cell module 1 two, each with 4 stacks. The blue is, I can't see it, the blue is the electrical balance of plant, and the gray is the mechanical balance of plant. So that is the most important parts of the power plant. An example, real existing example from the US. Here you can see the different parts in reality. Again, here is the module, electrical balance of plant, and mechanical balance of plant. Our products have a high availability and are very highly reliable. That depends, of course, on the quality of our products and also on the services. We have a contractual guaranteed output of our power plants, and we have a 20 years lifespan of our plants. You will ask for the lifespan of the stack. That is currently at 5 years. We enhanced that from 3 years now to 5 years, and the next enhancement is to 7 years. So lifespan of the stack is currently 5 years. We have a low maintenance level. No additional stuff at the client is necessary. We have multi-year service agreement with variable periods. Normally the agreement is over 10 years, and the stack exchange has to happen after 5 years, of course, because of the lifespan. In the agreement are included all planned and unplanned, if so, maintenance. Also no additional cost for material and stuff, so everything is included. And also, that is important, you already invest by the agreement into the next stack. So a big part of the agreement, of the cost of the agreement, is investment in the next stack, into the next stack. You will ask for the cost of such a system, and I can tell you that the price of our fuel cells are currently a bit less than 2,500 euros. Of course, this has to be further reduced, and until 2020, we should clearly below 2,000 euros. And that will be further enhanced by the Fraunhofer Institute. Here in the diagram is not included this further development by Fraunhofer. This will come on top, so it will be further reduced. Our fuel cell power plants have a huge variety where they can be applied. That is because we can put into the fuel cell natural gas, also biogas, and also, by the way, liquid natural gas is possible. And on the output side, of course, we have power, we have heat, we have, of course, cooling, and what we also can do is we can produce hydrogen. And another add-on which we can deliver is fire safety. That happens by extraction of oxygen, which is an interesting application for logistics, for example. So as I was mentioning before, we have an efficiency around about 47%. Our heat is extractable at 2 levels, by the way. And if it comes to cooling, we need to clarify what system the client wants to have and which systems should be added. And the hydrogen production is, of course, a very special thing. We have it in the US. It's really existing. I'll show you an example later. Quite interesting for hydrogen provision at the industry, at industries, different industries, for example, semiconductors, or at highways. So we identified, because of the input, we can use natural gas and biogas. We identified globally 11 market segments, 7 segments for natural gas, 4 segments for biogas, and quite interesting, it's possible to put such a fuel cell power plant on a ship. So this ship is existing, it's from Norway, it's a support vessel, and this ship is going to platforms, oil platforms, and they plug in and they get the power from the ship. This is a pilot, but it will be replied of course. As I was mentioning, we are able to provide hydrogen. This is an example from the United States, from Orange County in California. It's even more interesting because the hydrogen is produced from biogas. It's not from natural gas, but it's from biogas. So it's a renewable biogas, and we turn it into hydrogen, and it comes at a very high quality. It depends, of course, how much hydrogen you produce on the proportion. If you want to have more electricity, or if you want to have more heat or hydrogen, it depends. It's up to the client. Well, this is a list of plenty of advantages which come with our fuel cell power plants. As I was mentioning, fuel is flexible in fuel, natural gas, biogas, liquid gas. It's a reliable baseload power, and we can enhance grid stability, which is quite more and more important also here in Germany and in Europe. So we deliver baseload. That's a very important message. Quite often interested parties, clients come to us and saying we need to switch it off. That is, by the way, not possible, to make it very clear. We are supplying fuel cell power plants which run constantly for baseload input. So we have a very high efficiency, and the total efficiency goes up to 90%. Very important point, in particular, smart city is not a fashion, I would say it's already a reality. Smart cities are coming. We have a virtual lack of pollutants, and it makes it very interesting for applications in inner cities. Our company is based in Dresden, and it makes sense because Dresden is under pressure to keep the Feinstaub emissions at a very low level. So it makes sense to have such a plant, for example, in Dresden. But we will see it later. We have it in London already, and London is very keen to keep the emissions at a very low level, or at zero, actually. Our plants operate at a very low noise level and also without any vibration. And it's also very simple to do the maintenance. Okay, a short outline about outlook about the advantage in emissions. Our plants are below, in this case, German Emission Control Act, the so-called TA Luft, Technische Anweisung Luft. We are much below that, so it actually means we do not need a permission for our plants. And if we compare our technology to our competitors, to competitive technologies, we have to say we are much below our competitors, and we are definitely the benchmark in emissions. Now a few examples, some references. The first one is an existing one for a couple of years already. It's from Zurich. It's a small plant, 250 kilowatt, so-called DFC 250 EU. We had already a stack exchange. It was after 3 years because it was the old generation of fuel cell stack, or fuel cells. By the way, I'm running through the presentation, but it's available on the internet as far as I informed, for download. This is a very present example of a reference plant. It has not taken into operation, but it's already delivered, and it will be commissioned in July 2014. This is an example from Berlin for the second seat of our Ministry for Research and Education, and it's the size is also 250 kilowatts. I mentioned the two examples from London, quite interesting. London is keen to keep the emissions at an extremely low level. And so our fuel cell power plants makes it really the right, let me put it this way, ingredient for real estate developments in the city of London. For example, here we have the Q3 development. It's a mixed property development. And the main reason was keep the emissions low and have that in the inner city of London. The same here with a very famous building. It's Fenchurch. You might have heard about it in the newspapers. It's a really very, very up-to-date landmark building, or it's in the news. And we are very proud to have installed and delivered such one of our DFC 300 to Fenchurch. And it will be commissioned within this year. The building has not been finished at the moment. Yes, and at the beginning of my presentation, I was mentioning the development from where we come. It's actually from sub-megawatt plants a couple of years ago. Then we went to megawatt plants, but it's real. We are talking now about multi-megawatt power parks. We have here a couple of examples in California, for example. But Korea is a very strong, we have a very strong footprint in Korea. And we are very proud to present our recently finalized project within just 1 year. It's in Hwaseong City, South Korea, and the figure is correct, 59 megawatt. It looks like a village of fuel cell power plants. It's 21 times DFC 3000, comes from the US. The fuel cells are from the US with strong partners in Korea. And please join me now at watching the video from YouTube. You can download it and you can see it online. It's a pleasure to look at it, and thank you very much for your attention.